discrete Fourier series DFS, the principle of the discrete Fourier series DFS is very similar to the continuous time case. Okay, let's look at the basic ingredient of all Fourier representation transformed in the complex exponential. For the aej omega n is equal to a cos omega n plus ja sin omega n. For the sin and cos, as you can see, for the input formula of discrete Fourier series is xn summation of k from 0 to n minus 1 ck exponent jk omega naught n. And for the coefficient of discrete Fourier series is equal to 1 over n summation from n 0 to n minus 1 xn exponent negative jk omega naught n, for which is omega naught equal to 2 pi over n, and ck for k equal to 0, 1, 2 until n minus 1.
This is discrete Fourier transform DFT. So DFT apply only for a signal which is periodic and discrete. Periodic and discrete signal means discrete signal that repeats themselves in a periodic pattern. That you can see, this is periodic and that is discrete. So xn is the input signal and xk is the output signal. To gain xk, we need to apply DFT, while to gain xn, we need to apply IDFT, whereby xk is equal to summation of from n equal to 0 to n minus 1 xn times e to the power of negative j2 pi nk over n, while xn is equal to summation of from k equal to 0 to n minus 1 xk times e to the power of j2 pi nk over n, point where the signal, while xn is equal to summation of k equal to 0 to n minus 1 xk times e j2 pi nk over n. K is frequency parameter and n is the point where the signal repeats itself.
What we do in DTFT, basically we are transforming n to the variable of omega. N is time and this omega is the frequency signal. What DTFT do is transforming the discrete time to the omega. Even though we come from a discrete time signal, when we converted this signal to frequency domain, we will get the continuous output signal. So omega is continuous and it is not discrete, with omega is varying from 0 to 2 pi only. So what we can say that the frequency signal of omega is periodic and it is continuous. For now, x of n, when x of n is converted to x of exponential j omega, it is called Fourier transform. But if we want to transform this x of exponential j omega to x of n, it is called inverse of DTFT. Whereas x of n is a discrete signal and this is the continuous of omega. So this is the formulation of inverse discrete time Fourier transform.